Okay, so next I want to talk about two examples that are related to the fundamental theorem of calculus. And so two examples are, I want to compute z squared over gamma, where gamma is, say, t plus it, and goes between 0 and 1. And we can compute what we get. We already know what should happen, right? We're going to end up with, so this is an example that we saw previously, but we saw that this was t plus it squared times 1 plus I dt, where t goes from 0 to 1. And it turned out that this was negative 2/3 plus 2I. Now, what I want to do is let's apply the fundamental theorem of calculus that we just saw previously. So if we think about the fundamental theorem of calculus, we know that this function, little f of z, is differentiable on the entire complex plane. It's an entire function. That means that it's holomorphic everywhere. Okay, that's what entire means, is that it's holomorphic everywhere. It's got an antiderivative, capital F, which is going to be 1/3 z cubed. So again, not too surprising, very analogous to what we would do in the reals. And that means that this integral from z squared over gamma is going to end up being capital F of gamma of 1. So let's think about what's gamma of 1 when we are looking at this curve here, minus f of gamma of 0. And so that's going to be, well, gamma of 1 is going to be 1 plus I, because that's where the path ends. So no matter what the parameterization is, whether it's t plus it or t plus it squared, or whether we go kind of horizontally along the axis first and then up, whichever way you want to do it, f of gamma, well, gamma of 1 is 1 plus I, because that's the destination point, that's the final point on the path. And the initial point on the path is 0. And so let's think about if we have 1 plus I cubed and we take 1/3 of that. Of course, if we have 0 cubed and we take 1/3 of that, that's easy to compute, that's 0. But now 1 plus I cubed is going to end up being 1 cubed plus 1 squared times 3I plus 1 times 3I squared plus I cubed. And that's going to work out to be, so this is 1/3. We have 1 plus 3I minus 3, and then I cubed is minus I. So minus I. And that works out to, let's see, 1 minus 3 is negative 2. And 3I minus I is plus 2I. And that's why we kept always getting the same answer, negative 2/3 plus 2/3 I. Okay, so that's why this is always going to give us that value, as long as gamma is a piecewise smooth curve that starts at 0, 0 and ends at the point 1 plus I.